So let's have a look at how you might analyse data from experiments measuring respiration rates in germinating seeds. In order to do this, in this video I'll show you how to calculate the change in volume of oxygen over time, how to use control data to correct for changes that are not due to the independent variable, how to calculate the rate of respiration, and finally we'll compare respiration rates. In this example, the gas volume in the respirometer was measured in millilitres over a series of different times during the experiment, at time 0, 5, 10, 15 and 20 minutes during the experiment. And this was done for germinating peas, non-germinating peas and glass bees. Now, since oxygen is being taken up during respiration, you might expect that in the germinating peas the gas volume would decrease as a result of oxygen being taken up. But it is important, as demonstrated here, to have a control in your experiment, and in this case the control is the glass beads alone, because any changes observed here would account for changes in gas volume as a result of atmospheric pressure or changes in temperature during the experiment, and we need to account for these with the germinating peas and the non-germinating peas. Now, since this is a time series, the first thing that we should look at is how does the difference or change in gas volume vary over time. So we would obtain that by taking the value at a given time point, for example time 10 minutes, and subtracting it from the value at time 0. This second table shows the difference in gas volume from that start time, time 0, for each of the groups. That's glass beads alone, germinating peas and non-germinating peas. So in each of those cases, the value for a given time for that group was subtracted from the value for time 0 for that group. Now we know from table 1 that the gas volume decreased for germinating peas and non-germinating peas. And we can see here that the difference in gas volume from the start time is greatest for germinating peas across the entire time series. But as absolute values, we have to take into consideration the glass beads alone, because the 1 milliliter decrease you can see at time 10, 15 and 20 minutes could be as a result of changes in atmospheric pressure or changes in temperature during the course of the experiment. We need to take this into account, and we do so by taking the values for our control, the glass beads alone, and subtracting them from the values for the germinating peas and from the values for the non-germinating peas for each time point. Once we've done that, we obtain these values, which could be used to construct a graph with time on the x-axis and the corrected difference in gas volume on the y-axis. But if you would actually like to compare the rate of respiration of germinating peas with non-germinating peas, then you have to calculate the rate. Remember that rate is the distance, or volume in this case, divided by the time taken. So if we take the time to be 20 minutes in total, then the rate of respiration for germinating peas would be calculated by doing 19 millilitres divided by the 20 minutes, and for the non-germinating peas, 7 millilitres divided by the 20 minutes. This results in a respiration rate for germinating peas of 0.95 millilitres of oxygen per minute, and a respiration rate for non-germinating peas of 0.35 millilitres of oxygen per minute. So in this case, and as expected, the respiration rate for germinating peas was higher than that in non-germinating peas.